Sorry, can you be louder?
We did a sum.
Yes, we did a problem. And what problem was it? It was about, finding out the state diagram of your JK flip-flop, right? So ultimately, what we should try to do here, we should try to look for similarities and we should try to group them. We should not look for changes, drastic changes happening at every point of time. So here, if you can see, okay, we look for changes which is a little bit constant, right? So we look for 2 zeros, okay, and then we look for 2 ones. But in this case, I could not do that. So instead, what I did was, I look for grouping 1 and 1, and then I look for grouping 0 and 0. Okay. So ultimately, whatever is my data present here, okay, that should be mapped to my state diagram. Okay. So if I can do this successfully, okay, then that means I have mapped my S0 and S1, in a proper manner to my state diagram, right? Okay. So today we will discuss another new concept, okay, which is nothing but called state reduction and assignment. Okay. So I hope all of you have taken down this table. Have you all taken down this table? Yes, no.
Yes, sir.
Okay, fine. For those of you who have not taken down, okay, just make sure that you copy this information because we'll be solving, okay, problem based on this, right? So this is a random table that I've put up here, okay, where this is my present state, next state, and my output for two values of x, which is 0 and 1. X is equal to 0 and x is equal to 1. Then outputs for x is equal to 0 and x is equal to 1, right? So here, can someone tell me what kind of table is this? Is it a state table or is it a transition table? What kind of table is this, or is it a truth table? What table is it?
Transition.
Yes. State table. How is it a state table? Rohit.
Sir, it's the present state, next state is.
So you call it a state table?
No, sir,
Fine.
that was different.
So this is a transition table because we have coded them, right, with A, B, C, D. Fine. So let's take it here in order: A, B, C, D, E, F, G, right? And in the next state, okay, next state also I have some values, and in the output also I have some values. Fine. Now let us deeply see here what is happening. Now, if you consider at state E in the present state, okay, the next state is AF, and the output is also 0, 1. Now, if you see G, okay, the state is AF, next state, and the output is 0, 1. So in this case, what I can do is I do not want to have an extra state G. Okay, extra state G is not required. Okay, so I can delete it because this same information I already have here. I already have this information there. So I will not like to have duplicate information. Okay, I will not like to have someone else telling the same information again and again, no repetition. Okay, so in that case, what I will do is I will make sure that I nullify this last state. Okay, so how do we do that? Before we do that, what we will do is we will draw a state diagram for this. Okay, and after doing the state diagram, then we will start a reduction of the states. Right? Now, I hope all of you have taken down this, and now I want all of you to start drawing the state diagram for this table. So I have the table for you. Start drawing the state diagram.
Sir, is it necessary for the state diagram to be circular?
No, not circular. I mean, like it can happen from one end to the other end. You can take any form, whichever you wish to, not only circular. You can take triangle if you like. You can take an octagon if you want.
So, sir, can multiple lines cross each other? Like, is that fine?
Yeah, it can happen. Why not?
Okay,
Are
sir.
you all done, or should I show you the answers? Ultimately,
Done.
what you should do, you should make sure that this information is mapped into a diagram. So the best way is to go present state wise. First go with A, B, C, D. Okay, you will have options for 0 and 1. Here also you'll have options for 0 and 1, right? So all of you have done the state diagram, or you need some more time?
Done, sir.
Okay, Sachin, or you can show me your state diagram.
Yes, sir. Can you see, sir?
Just a moment. Okay, now can you explain what you have done?
Sir, so when the input is 0 and output is also 0, it will be in the same state, A. And when it is 1 over here, we go to the next state, that is B. And at B, if we have the input as 1 and output as 0, we go to the next state, that is D.
Okay.
And when we are at D, and when we are at D, and when input is 1, we get F here. And
fine. So you have done your part. Good. Sachin, you can turn off the video if you wish to. Yeah. Right. So you all can have a look here, okay, as to what the diagram is. For those of you who have not done it, okay, you can make a note of it as well. See, ultimately, what I'm trying to say here is, you should introspect yourself, and you should check if the diagram that I have put up here is matching with the one that you have done. Okay, so that's the way you learn. If not, if you do not take things seriously, then it becomes difficult for you to understand the concept. Now, I think most of you are very much aware as to how to draw a state diagram given a table, okay, or given some information. So we are very much aware as to how to create a table, how to create a state table, okay, from the state diagram, and how to create a diagram from a table, right? Vice versa also, right? So now let us code them one by one, okay? Now A I'll be giving as 000, and accordingly I will start, okay, from 000. So 0, 1, 2, 3, 4, 5, 6. So G will be 6, okay. Fine. To get the smallest state diagram, we should apply the state reduction by reducing the steps. So what we have to do here, we have to reduce these repetitions, and we have to just make sure that these do not occur multiple times in the same tabulation. Right. So if its next state and output are same, we can reduce the states. So next state is also same. Okay, as you can see here, next state is also same, and then output is also same. So in that case, we can actually consider that it's a repetition, and we can reduce it. From the state table, okay, AF is equal to 0, 1. AF is equal to 0, 1, which means output is 0, 1. Here also AF is equal to 0, 1. Okay. For E and G are the same. So I will eliminate G. Okay. So therefore E is equal to G. This is very important. Okay. Please make note of this. Okay. E is equal to G. So state E is equal to G. So very important, substitution that I'm trying to do here. Okay. Just make note of it. You can write down these. And then you can make sure that you have written that AF is equal to 0, 1 for E and G, and hence G is eliminated. Please make note of these statements. And here you can see that E is equal to G. So since E is equal to G, okay, the last one F, okay, 0, 1, okay, of G is eliminated. Okay. So now if I eliminate that, okay, so this becomes my modified table. Okay. Now I have A, B, C, D, E, but where is F? Where is F? F is what? F is actually G and F, right? But since this is also 0, 1, okay, we have done a substitution here. Okay. And we will see what kind of substitution is happening here. Okay. E is equal to G, okay, and then F0, 1 can be deleted. Then G, F0, 1 can be deleted. So what I'm trying to do here is, okay, for state E, okay, for state E, I am giving as G, okay, because I got E is equal to G, right? So here instead of E, I will write as G. Okay, so instead of E, I will write as G. Okay, so here again you can see that I have GF, I have GF, okay, I have 0, 1, I have 0, 1. So again, 1 can be eliminated here, yes or no? Okay, so which means D is equal to F. Yes, D is equal to F. Okay, so this is going to be my modified table. So ultimately I will have, just take note of this table and compare with your previous table. Did you understand, students, how we got this table? Any doubts here?
Sir, can you explain that reduction once again?
Once again, you want to know? Okay. See, now what we are going to do here is, we are taking AF, here also it's AF 0101. So, which means present state E is equal to G. So, wherever I have E, I will substitute with G. Okay. So, here I had E. So, what I will do, I'll substitute with G. So, what will happen? GF will happen. So, if GF happens, here also I have GF, right? So, which means D is equal to F. So, again, this one also I can eliminate, yes or no?
Yes, sir.
So, two states are eliminated. So, which means I have only A, B, C, D, E. So, just come down here. A, B, C, D, E. That's it. Understood? Is it clear or
So,
not?
sir, the state F is also deleted.
F is also deleted. How is it deleted? See, first this was E. Okay.
Yes, sir.
And what happened here was I first deleted this. I first deleted this because these two were same. These two are same. So when I say those two are same, what I will say, E is equal to G. E is equal to G. So here instead of E, what I will write is, I will write G. Okay, I will write G. Now again do a comparison. Now if you do a comparison, now these two are same, right? GF here and at the output also it's the same. Yes or no?
Yes,
See
sir.
here, it is GF because I changed from E to G, and then it is 0, 1, and here also it's GF, okay, and it is 0, 1, isn't it? So what I will do, I will eliminate this one also. So ultimately, I will have only from A to E alone. Understood or not?
Understood, sir.
So this is
Sir,
your
so if
modified
D
table.
was 0, 0, we couldn't do this, no, sir?
Which one?
If D was 0, 0,
If D, no, we can't do. See, only my outputs should be same, and my next state should be same. These two should match. Only then we can do that. Okay. So the one in orange is our modified table now. Okay. Right. So that's why I have written here. See, E is equal to G. Okay. So that F01 can be deleted. And then what I do, this G, okay, the last state can be deleted. Fine. So here what is going to happen, I've written for your understanding that D is equal to F. So this is our modified table. So you can take note of this modified state table now. Okay. So once you have taken note of it, you can go ahead with the state diagram as well. Are you all done with the state diagram?
yes, sir.
Okay. So if you can compare both of them, okay. So this diagram seems to be very simple, right? But compared to your previous diagram, okay, you can see that it was a whole lot more complex, than the previous one, right? So what do we try to understand from this problem? We try to understand that we can reduce the graph in a much better way, okay, when we try to apply the techniques of state reduction and assignment. Okay, so we have a huge graph here just because we reduced three states, okay, no, two states. So because of that, what happened, we were able to get a reduced or updated table, a minimized table, and also we could have less number of states, okay, only A, B, C, D, E, okay, and our graph is also minimized, which means it is more fine-tuned. Okay, so students, you can make a note of this graph as well, state diagram. So any doubts here that you have so far with the concepts discussed? Students, any doubts?
No, sir.
Okay, fine. The only key here is to practice. Okay, so just look at the problems and try to solve them. Okay, you should practice, then only you will be able to understand these. If not, then it's going to be more confusing unless you practice them. If you just sit and listen, no, it's not really going to help. For exam point of view also, problems can be asked of any sort. Okay. All of you done with the diagram? Yes, Surya, you can tell me if you have a doubt. Yes, you can unmute and respond. Surya, you can unmute and respond. What doubt is it?
Sir, in the truth table, I mean, in the state, I mean, the table, sir.
Huh.
Why have you written F? We could write it as D only, no, sir.
Which one?
The table.
Table, the last second one.
F. Yes, sir. F is written.
Okay. So here you want me to replace with D?
Yeah, sir.
Even if I replace with D, no problem. That's also fine because D is equal to F, right? That's also fine. Here also D you can write, here also D you can write. But there is not going to be any more reduction, right? So it's fine even if you substitute or you don't substitute, it's fine. See, because say for example, I write a D here. So it's ED and AD. I have another AD, but it's 0, 0 here and 0, 1 here, right? So there's no point in actually, getting that replaced with D. Understood? So either of anything is fine. Is it clear?
Yes, sir.
Okay. So I think we will end our class here, and we will try and discuss in the next class the upcoming concept. Okay, very important concept, which is actually sequence detector. Okay, for sure you will have a problem like this, the sequence detector. Okay, we'll have to draw a graph like this, and okay, for a bit stream, we will have to find out if if it's happening, if we are able to recognize a pattern and things like that. Okay, so these concepts are important. Okay, so we will discuss that, and then comes your counters. Okay, a very interesting section. Okay, where we will be designing counters. Okay, so these are few topics left out. Okay, and then afterwards design of ALU, right? Okay, so fine then. So we will catch up in the upcoming class. Okay, and any doubts, then we can always have a discussion.